Okay, in last video we have seen flops, how to calculate floating point operations per second performed by your CPU. If number is big, it's in 10 to power 9 order, then we used to call it gigaflops. If it is in order of 10 to the power 12, we called it teraflops, right? Now we are continuing our discussion. In last video, we also seen the code. So if you want to really see exactly how to calculate that, you can see the code and you can try and execute that code in your machine and you can see your CPU's capacity. Here today we will actually go even deeper and we'll see some of the statistics related to CPU. So let me show my task manager of my machine, and there are some statistics I want to talk about, and we'll go in details about each and every statistic here so that we will understand our CPU better. Now please do remember we are talking about CUDA programming here, but to understand how GPU works, CPU is more familiar for us. So if we understand CPU better, it's much easier for us to understand GPU, and then we will go with that journey in later videos. But do understand CPU related metric here so you can compare and contrast with GPU in later part of the videos, right? So let's start with base speed. Base speed is also known as clock speed or clock frequency. That means number of operations your CPU is capable of performing in 1 second. That means number of operation it can start in 1 second. That doesn't mean it can execute those number of operations in 1 second, because some operations might take more than one CPU cycle. So you will see some lesser number of operations got completed. So it's in gigahertz here. That means it is capable of performing 2.10 billion operations in 1 second. Now here you see speed and base speed. So this is the minimum speed. That means base speed is the minimum speed you will get here. This is turbo speed. This is, you can say, keep on changing, and it's on top of this base speed. That means it's on turbo mode, utilizing more power. But whenever you want to perform any calculations, you can always go ahead with the base speed. You cannot actually rely completely on this. It is usually utilizing more power and dynamics, so your calculation might go haywire if you this number doesn't support you, right? So you should always calculate based on base speed, right? Now this machine has only one CPU chip socket. That's why this sockets here is one. It has 20 cores. That means your CPU or this machine CPU has 20 cores. In earlier days, we used to have only one core in the CPU, and all the instructions you see will be performed on that one CPU. We used to have multi-threading, and in multi-threading you will get the illusion that multiple threads are running simultaneously, but there were context switching, and memory gets stored in the register, and then it was switching so fast that we can actually understand, or we started feeling that it is happening simultaneously. One classic example is you can do programming as well as you can hear songs on VLC or Winamp at the same time. You get that illusion that something is happening simultaneously, but it was context switching, right? With these 20 cores, you can actually run 20 threads parallelly, literally simultaneously on different cores. Now, these threads can be from one application, or these threads can be of different applications as well, but they are actually running simultaneously. So, instruction by instruction, all CPUs will run these multiple sets of instruction, right? Now here you see logical processor 28. That means you have 20 cores, but logical processor is 28. There is something called hyperthreading. When some CPU cores are capable of running more than one thread, so, usually two threads simultaneously. Now, before I was researching about this particular video, I always thought like CPUs or CPU cores are always capable of hyperthreading because this is a software phenomenon, but I was wrong. I understood that not all cores are capable of performing um, hyperthreading. It's a manufacturer's decision, and they need to actually build that core in a specific way to support hyperthreading here, right? So that's why you see here 8 extra cores. That means 8 cores in this machine are capable of hyperthreading. Others are not. That's why you see logical 28 processors and physicals are only 20 processors. Now virtualization, you if you came across Hyper-V, where you actually run virtual machines by creating virtual machines in the same machine, or then there are other softwares as well, those support virtual machines. If this is enabled, this is just indicating that that kind of support is there. You can do virtualization on this particular machine right now, right? Now this L1, L2 and L3 cache it's a cache of your CPU where CPU keeps the data which it immediately want to access, right? So L1 is the fastest cache. So most immediate and the smallest cache is L1 cache. I am talking about proximity. It's the nearest one for the CPU and it's the smallest one, and that's why it's the fastest one. Now why smallest is the fastest? Because to search some data it happens quickly because memory is very small here, right? As memory grows, speed actually decreases. So L1 is the smallest memory, fastest one. L2 is little bit less faster than L1, and L3 is the slowest. Although its slowest also is very fast here because it's very near to CPU, and CPU need not to go again and again to RAM. It can actually manage all those things here. But again, if we just want to compare these three, we can actually compare that way. Now you can see it is only utilized 8%, though I'm recording video here and this task manager also running. Probably many applications in the background are running, but it's a powerful machine. That's why only 8%, 9% CPU is being utilized. There are so many processes, so many threads are running simultaneously. So this is how we can actually see our CPU's configuration or CPU statistics in our machine. In later part of the video, I might start with GPU related topic, but if I find something interesting which will help us in later point of time to understand our GPU better, and that will indeed help us in CUDA programming, I will definitely take those topics. But right now, I think I'm planning for GPU related videos in later videos, right? So thank you so much for patient listening. Goodbye.